So this video is probably going to be one of the longest ones that we've done up to date. It's a lot of information going into lesson 5.4. Lesson 5.4 is going to be looking at how to find a percentage of a certain quantity or a certain number. When we look at our percentages of a number, we first have to understand that when we say of, we are talking about multiplying. So we're talking about doing math. The other thing that we have to understand is when we're talking about a percentage, going all the way back to lesson 5.1, when I introduced percentages to you, I said we can't use a percentage in a math problem. That's why we have to figure out how to do the fractions and the decimals and how we're going to use it. So one of the reasons why the video is going to take so long is because some of you are going to prefer to do the fraction form. Some of you are going to prefer to do the decimal form. I don't care which way you do it as long as your math is correct and you get to the right answer. So on each of the questions that we work through, I'm doing both ways. That way, each person will have the example that they need that they're more comfortable with. So when we start out, we're talking about a typical family of four uses about 400 gallons of water each day, and 30% of the water is for outdoor activities such as gardening. And asks, well, how many gallons of water does a typical family of four use each day for outdoor activities then? So when we're looking at it, this one says to use a ratio with the reasoning and how you're doing it. So a ratio, once again, is a fraction form. So that's how we're going to start this one out. So when I look at it, they give me this box. And some of you are just like, I don't even understand what that is showing me or what it's saying. So let's take a look just what it's trying to tell us. So when we remember about from the very beginning that we're talking about ratios, we're talking about percentages looking like ratios or percentages looking like fractions, we're talking about having a denominator of 100 every time. So when I look at this, what I have is 400, and notice I'm dividing it into equal groups. And I'm dividing it into 10 equal groups. And if I talk about 10 equal groups, and then on the bottom is showing me, well, I'm only using 3 of those. So if I take this and I put it into 10 equal groups, I know each of those is going to be worth 40. And I know I'm going to be talking about a numerator of 3, because that's how many I'm going to keep. So when I talk about doing this, I'm talking about using 3/10 of the whole number that I'm talking about. 3/10, once again, thinking about percentages, is the same as 30 over 100. That's an equivalent fraction. And we know, once again, that a percent is just a number over 100. So what we're talking about is just using this information and using it in a fraction form. 30%, as we just said, is the same thing as 30 over 100. So when I'm talking about it, I'm talking about having 30 over 100 and then reducing it down to the 3/10 that we're talking about, 3 out of the total 10. And it says, well, I'm going to find the of, and we know that of means what? Of just simply means that I'm going to multiply. All the way back to Unit 1 and Unit 4, we've been talking about how to multiply with fractions. So when I know that of means to multiply, then I'm going to set it up as 3/10 times the 400 gallons that they tell me about. I put the 400 gallons over 1 because I can't multiply by a whole number. That gives me 120 gallons. Now notice, if you just did it working ahead, you got 1,200 over 10. But if I cross-reduce first, and in this case I can just drop those zeros off, cross-reducing is going to save me a lot of steps and a lot of reducing throughout all of these problems because we're going to be using bigger numbers. I can't encourage you enough to learn and to use cross-reducing. It is something that you will learn in 6th grade, 7th grade, all through junior high. You'll use it in high school when you get in your advanced math. You'll use it in chemistry when you're doing different types of equations. Cross-reducing is an easy way to eliminate bigger errors along the way. So when we look at what this is saying when we fill it in then, it says to think that 30% is 3 groups of 10%. So you're going to divide the model into 10 equal groups. That's what the box was showing us. It says to find the value of what 10% is. So if I'm talking about 1/10 of 400, then I'd have the 400 over 10, so I know that that value is 40 per box. It says find the value of what 30% would be then. If each box was 40 and then 40 and then 40, I'd have my 3 times my 40, which is going to tell me that I have 120 gallons. The 120 gallons is what we just found before. When I do the math for the fraction that the percent comes from, and I have 1,200 over 100, then when I reduce, I get 120. Are there any other ways that we can do it then? And that's where some of you are going to prefer to change it into a decimal instead. If I take my 30% and I know that I want to use a decimal, then the shortcut for that, once again, is drop the percent sign, move the decimal from right to left 2 times. So if I move it 2 times, I know I have 0.30. I don't use that 0 at the end of it. So I am going to find out what 3/10 or 0.3 of 400 is. So I have to set it up. It becomes 400 over 0.3. And 400 over 0.3 is going to give me, when I multiply, 3 times 0, 3 times 0, 3 times 4, 1,200? No, because in multiplication we count our decimal points, don't we? So I count my decimal points. I have 1 decimal point. I move from right to left 1 time. That once again tells me I have 120 gallons. So there were 3 different ways that I worked through that math problem alone, but we're going to focus in on just doing it the 2 main ways. Either using a fraction or using a decimal. So on this one, I'm going to use 65%. Now on the left, I'm going to do percents, or fractions, and on the right, I'm going to use decimals. Okay? So if I change 65% into a fraction, once again, I take that percent number and I simply put it over 100, reduce if I can. When I'm talking about the decimal, I drop the percent sign, move my decimal from right to left 2 times. Those are always the steps when I'm doing that. So that give me 0.65. So every time it's the same thing. So when I reduced my 65 over 100, I got 13/20ths, or I kept my decimal point of 0.65 as the 6,500 said it would be. So then we have to do the math. Once again, please be taking your notes, following along, and doing the steps, because I'm going to do a lot of different problems. And I want you to truly understand this, because this is a strong foundational piece for being a successful 6th grader, but also something you're going to carry on for several years. So when I have 13/20ths times 300, once again, that's my fraction of 65%, 65 over 100. I reduce it down to 13/20ths. I put it over 1 because I can't use a whole number. I'm going to cross reduce. 20 goes into 20 once. 20 goes into 315 times. If you don't see that, handy dandy calculator, type it in. 300 divided by 20 equals, you're going to get your 15. It's much easier that way. And then this is all the steps you need to show me. I'm left with 13 times 15. Once again on my calculator, 13 times 15 equals 195. When I'm looking at doing it with a decimal then, I have my decimal point of 0.65 or 6,500ths, and I'm going to multiply it by my 300. So I start with my 5 and do my 5 times 0, 5 times 0, 5 times 3 is 15. My second number tells me to bring down a 0. I can't forget that when I'm doing my decimal point multiplication. I have to bring down that 0 or all my answers are going to be wrong. So then I multiply with my 6. 6 times 0, 6 times 0, 6 times 3 is 18. And when I add those together, I get 195. Multiplication of decimals. Count my decimal spaces. So I'm going to move it from right to left 2 times. I still get 195 as my answer. So what I want you to understand is that I have two different paths that I can go on. I can either choose to do my fractions or I can choose to do my decimal. I don't care which one you do because it's what are you best at. That's what I care about. Do you understand it? Do you know how to do it? And can you get to the right answer? If you prefer to do it with fractions, and you can answer those as yes. If you prefer to do it as decimals, you can answer those as yes. Then choose either way. You're still going to get to the same point either way. You should still find that your answer is 195. So let's look at the next example they give us. It's a lot of information, but it really is a very basic math problem. We're going grocery shopping. We have some groceries that we bought, We have $4,000 per month that we make if we are Charlotte. I don't make that much, so I'm not sure what kind of job Charlotte has. Maybe I need to figure that out. But it says she spends 40% of her salary on rent, 15% of her salary on groceries, and then it wants to know, well, how much does she have left? So all of these are just steps to think about how to get to the actual math problem we need to do. It says first we're going to look at the 2% that we know are spent on bills that have to be paid. One is the 40% for her rent, and the next is the 15% for her groceries. Those are monthly bills that are going to be paid. So we know that she's going to spend 55% of her salary. Well, what the question is asking, well, how much does she save? So I'm going to take my 100% of my salary, I'm going to subtract my 55 from it, I know I'm going to use 45% is what she saves. So that's the percent I'm going to use in my math problem. 45% is either going to look like 0.45 as a decimal, or 45 over 100 reduces down to 9/20. Either way is going to get me to my math problem. Now if you don't see where those came from, then once again my 45%, drop the percent sign, move the decimal from right to left 2 times, gives me my 0.45. When I have it as a fraction of 45 over 100ths, I'm reducing by 5s, and that's going to give me my 9/20. So just in case you didn't see where those came from, that's where I got those numbers I'm going to use. So I'm going to do my math. Once again, decimal point on the left, fractions on the right. When I multiply by 45 hundredths, I end up getting $1,800. So I multiply by my 5s, and I got 2,0,0,0,0. And when I multiply by my 4, I brought down that 0. Once again, very important in multiplication of multiple step numbers. And then I got 1,600,000, which gives me 4 zeros after an 18, but I have those 2 decimal spaces. So I move it from right to left 2 times, and that gives me my 1,800. Setting up the math problem as 4,000 times 0.45, typing it into my calculator, 4500 times 0.45 equals, then I know that I'm going to get 1,800, makes my life a lot easier. When I use my reduced fraction of 9/20, that once again came from my 45 over 100ths, then I'm going to multiply it by 4,000 again. But this time I once again have to put it over 1 because I can't use that whole number. All of these problems are going to be remembering to put that whole number over 1 before I do the math. I once again am going to cross reduce because it's going to make my life a lot easier. And when I cross reduce, 20 goes into both of them. I end up with 9 over 1 and 200 over 1. And 9 times 200 is indeed $1,800. So both ways I get to the same answer. It doesn't matter which way you choose, as long as you get the right answer. That's what I want for you. So 1,800 would be the right answer. So here's where we're going to work through all these problems in 2 different ways. So on my first one they give me, it asks, well, what is 25% of 320? They kind of give me some wording here to help me get it set up to remember how to look at it. 25% is equal to 1/4. So use blank equal groups. Well, How in the world do I know what the equal groups are? Well, it's actually pretty easy because my denominator always tells me how many equal groups I have. My denominator is a 4, so I know that I have 4 equal groups. And if I have 4 equal groups, I have 1/4 times 320, so I'm going to have my denominator of 4, and I know that each of those is equal to 80, because 320 divided by 4 is 80. I could have cross-reduced, and 4 would go into 4 once, and 4 would go into 320 80 times as well. I would still get to the same answer. I apologize, it just said that my battery's going low on me, and I want to be able to finish my video. Alright, so on my next one then, I'm given 80% of 50. Now I look at my 80%, I've got my fractions, I got my decimals. My fractions, I take my 80, I put it over 100, and then I reduce. When I take my percent and make it a decimal, I drop the percent sign, move the decimal from right to left 2 times, and I get 0.8 to use. Once again, I would have 0.80. I don't use zeros at the end of my decimal numbers. So working through just the fraction first, and then I'll work through the decimal. Working through the fraction, I take my 4/5 of, which is times, my 50, which they give me. I can't use my whole number, so then I have to set it up over 1. You wouldn't have to rewrite the math problem, just show me that you know to put it over 1. Then I would strongly suggest on every one of these, I'm going to do it, cross-reduce. 5 goes into 5 one time, 5 goes into 50 10 times. When I multiply across, that leaves me with 4 times 10, which is 40 over 1, which is telling me that my answer is indeed 40. When I look at my decimal points then, I have my 50, which came once again from problem 1, times my decimal point of 0.8. I multiply the digits, 8 times 0, 0. 8 times 5 is 40. 1 decimal space, so I move it from right to left 1 time. Once again, same answer, 2 paths to get there, but I still get to the same point. So my answer is 40 for question number 2. When I look at question number 3 then, it asks about 175% of 24. Well, 175% is what I'm using, so I'm going to set it up as my percent, or as my fraction. I'm going to set up my percent as a decimal. I put 175, whatever the percent is, it doesn't matter that it's over 100. I put it over 100. I can have an improper fraction. When I reduce those then, if I think about quarters, 25 cents, 25 goes into 175 7 times, and 25 goes into 104 times. So I reduce by 25s. To do my decimal point, I simply drop my percent sign, move the decimal from right to left 2 times, and it's just 1.75. We'll talk about how to set that one up here in just a second. Coming back to the fractions then, I'm going to work with the fractions and do 7/4 of 24, and of once again tells me to multiply. So I take 7/4 times 24, has to be over 1, because I can't do the math without it being over 1. So I simply rewrite it. I see that I have 7/4 times 24 over 1, and that 4 will go into 24 evenly. So I reduce by 4. 4 goes into 4 once. 4 goes into 24 6 times. So I'm left with just multiplying across. My denominator is 1, so I don't need it. But 7 times 6 is 42. Now, when I see that I have a 24 here, and I have a 3-digit number here, this is where my multiplication facts, they let me know that it doesn't matter what order I put them in. I always put my number with the most digits on top. It's just much easier, and there's fewer mistakes that way. So I'm going to put the 1.75 on top and multiply by 24. So then I multiply by my 4s, and then I multiply by 2s. So I see that I get multiplying by 4, 700. I get 3,500 when I multiply by my 2. Remember to bring down that 0 when I'm doing my multiplication, and then I simply add them together. Now, once again, I'm not really slowing down on this video because it's already going to be one of the longest videos. But if I'm going too fast, please pause and finish your work so you know what you're doing. If you need to get scrap paper and attach it inside your book, please do so you have all these examples to go back and look at every single time. Both ways, two paths to one answer, still shows me that my answer is indeed 42. My last one out of this set, then, it shows me that I'm asking about 60% of 210. So I have to use my 60. When I look at it as a fraction and as a decimal, I put 60%, I put the 60 over 100, I reduce by 20, and 20 goes into 63 times, 20 goes into 105 times. When I take it and make it into a decimal, I simply drop the percent sign, move the decimal from right to left 2 times. It would be 0.60 once again, but I'm only going to use the 0.6. I don't use the 0 at the end of the number. So I'm going to then do my math. Once again, it's of, so I know I'm going to multiply. So I set it up as 3/5 times the 210 that it talked about. I can't use 210 in the math problem by itself, so I have to put it over 1. I see that 5 and a 0 are at the end, so I can reduce by the 5. 5 goes into 5 one time. 5 goes into 210 42 times. And then I multiply the 3 and the 42 to get 126. Pause if you need to. If not, we're moving on. So with my decimal then, I'm going to take the 210 and put it on top, and I'm multiplying by, we said 60% is the same thing as 0.6. I multiply by the 6, and I get 1,260. Once again, one decimal space tells me to move from right to left 1 time. So that still gives me 126. 2 routes, 1 ending, with an answer of 126. Now the last 2 things that they give us are story problems to look at. And we have to know what it's being asked and how to use it. So we have to stop and think and truly, please, read the story problem. There are so many of you that come to me and you're like, I really don't know what it's looking for. You have a completely wrong answer. And when I ask, did you read it? You honestly, and I appreciate you being honest, tell me no, I didn't. Got to read it and comprehend what it's saying. A jar contains 125 marbles. Given that 4% of the marbles are green, 60% of the marbles are blue, and the rest are red, well, how many red marbles are in the jar? So I'm looking at green, I have 4%, and blue, I have 60%. So when I take my 60 plus the 4, I get 64%. But I once again want to know about red. So when I have 100% of the marbles, and I know 2 of them make 64%, I subtract, I know I'm talking about 36% are going to be red. Then I do my math. With my 36, I start with making a fraction, I start with making a decimal, depending on which one I'm better at or choose to do. I put my 36 over 100. On this one, I reduce by 9, or by 4, excuse me, because 36 divided by 4 is 9. 100 divided by 4 is 25. So using the 9/25 makes my math easier as I work through because I don't have larger numbers. So my 9/25 times 125, got to put my 125 over 1. Cross reduce, 25 goes into each of those. So 25 goes into 25 once. 25 goes into 125, or there are 5 quarters in $1.25. So it goes in 5 times. I'm left with a 1 as my denominator, which I don't need, and therefore I multiply 9 times 5. It tells me that I'm going to have 45 red marbles. Well, I check my decimal, make sure I have the same answer. So I'm going to use my 0.36 or 36 hundredths. I'm going to multiply it by the 125 marbles that tells me I'm starting with. I multiply by the 6, then I bring down a 0 and I multiply by my 3. When I do that math, I'm left with 4,500, but remembering that I'm multiplying by a decimal, I count my decimal spaces and move that decimal from right to left, in this case, 2 times. And once I do that, I do get 45, which is the same as what I got over here. So I know that I have 45 red marbles. Now, caution, to get the proper credit, I can't just put marbles because I have 3 different colors of marbles I'm talking about. We had the issue with several of you on the paint questions. You just put paint or quarts of paint or just quarts, but we had yellow and red and I needed to know which one. So some of you had to come back and correct that one. Let's make sure we're specific on our labels. So on the next one then, on question 6, it says there are 32 students in Mr. Marino's class, and 62.5% of the students are girls. How many boys are in the class? Now I remember this question from last year because before they even worked it, I had students asking me, well, how can I have 62.5% of girls? Did we have somebody that wasn't whole? No, that's not the case. Okay? So percents doesn't mean that we have a part of a person, and we're just talking about an overall percentage for a class, and as we work it out, you'll see that it is indeed going to be a whole number. So I'm looking at 62.5% are girls, but I'm asking how many are boys. So once again, that's not the percent I'm using in my math problem, just like with the marbles. So I have to take my 100 and I have to subtract 62.5%, but that doesn't have a decimal on it, does it? Well, that's okay because I just add the decimal in 0 so that it lines up and I can do my subtraction. So I borrow through and I subtract, and what I get is 37.5%. So I know 37.5% of Mr. Marino's class are boys. And then I do my math to solve for how many boys there are. So when I set it up, I know that 37.5% is 37.5 over 100. So in the last 2 lessons, we've looked at how we would just change that to where at a different denominator. It would be 37.5 over 100 to start with, but if I multiply each of these by 10, then I know I get 375 over 1,000. Then I can reduce each of them by 125. Now, I'll be honest, I used my calculator for that one because I knew 5 would work, but I still ended up with a larger number than I needed to because I could reduce again. So I looked at it and used my calculator and found out it was 125. The overall fraction I'm going to use is my 3/8. So when I set it up as 3/8 times my 32, because I'm looking for what is 3/8 of my 32 students, I put my 32 over 1. I cross reduce with my 8, which would give me 1 and 4 once I cross reduce. When I multiply cross then, I end up with 12. So we end up with a whole number. We don't end up with partial students. When I do my percent as a decimal, once again, drop the percent sign, move the decimal from right to left 2 times, it gives me 0.375. Once again, like a previous question, I'm going to have 3 digits compared to 2 digits, so I'm just going to put my 0.375 on top. I can do that with multiplication and addition because once again, it doesn't matter what order I do them in. I multiply by my 2's, bring down that 0, multiply by 3's. That gives me 12000 once I add them, but I have this times 3 decimal spaces. So I know I move my decimal 0.3 times. Once again, I get 12. It's 2 routes, same answer. I know I have 12 boys in Mr. Marino's class. So this is a long video. It's going on about 30 minutes now, and I apologize for that, but there's just a lot to do here. And if you like decimals, I want you to see me working through decimals. And if you like fractions, I want you to see me working through fractions. But the key is that you're going to be asked to do both throughout the remainder of the year. So it's important to know how to do both steps and both ways. But understanding that once again, when we say of in a math problem, 95% of the time, there are those few that are tricky, and they do try to trick you by putting it in a different place. But 95% of the time when we use of with a number, we're asking you to multiply. And once again, when we're looking at this, we're talking about percents, and I can't use a percent in a math problem. So if I choose to do this problem, and I need to set it up as a fraction, or I need to do this problem and I want to set it up with a decimal, it's up to you which way you do it. I don't care which path you go through, as long as you get to the same answer. That's the important part for me, that you understand it, that you're able to do it, and you're able to repeat the steps over and over and over again. This is a quick video when it came to working through the problems, but it's a long video overall. Please, if you fell behind in your book and things, stop the video, rewind, go back, fill it in, because if you don't do it and you don't practice with me, you're not going to understand. If you have questions about it when you're doing your assignment, please come and ask. If not, look at the board and do the work.